So in lesson number 2, we're going to talk about 802.11 security. Very, very short chapter. Just talk about what is open versus shared key authentication. How do we incorporate the use of TKIP in 802.11? And then we'll talk about some basic additional security measures that we can apply to 802.11. The idea is to apply the same level of privacy that we would expect to get from a cable. That can be a challenge. I mean, it can be a very technical process. We will gain steam as we kind of move through these different lessons. Some of these lessons are pretty basic, and it kind of just introduces a lot of these different concepts. But we will continue to pick up steam as we move forward and get even more in depth into a lot of these different topics. In an 802.11 compliant wireless LAN network, right? The client is going to use open authentication by default. Open authentication operates at the physical and the data link layer, doesn't offer any end-to-end security whatsoever. It kind of implies that the association is used when the user should be able to access the network with little or no effort, I guess, for lack of a better term. So what's the process for verifying a device that wants to connect using this open authentication method? Well, number one, you can see it on the diagram here, the client sends a probe request. The client receives a probe response from the AP. The client then sends an authentication request to the AP. The AP authenticates the client. The client sends an association request to the AP. And then finally, the AP confirms that association, assigns that unique ID, it's called an association identifier, to the client, which is essentially the number in the cell, and the device can then start sending and receiving within that particular cell. At this point, the client device has only authenticated itself as an 802.11 capable device. There's no encryption, there's no per packet authentication, there's no message integrity checking, and we may want to choose then to go ahead and add additional security features on top of that, like 802.1x and WPA2, Wi-Fi Protected Access 2. If I follow the same process, and now I use a shared key, shared key is initially basically like open. The only difference is that the key is required on the client and the AP, and by using that particular key that's been configured, the authentication process adds what we call a challenge and response between the AP and the client. Specifically, the process that we use for this is wired equivalent privacy, or WEP. Now, while it does provide some security for the data that's actually traveling over the wireless network, there's a lot of problems with this particular solution, a lot of drawbacks. Doesn't authenticate each packet, so man-in-the-middle attacks are always a possibility. And because, of course, it's a static key, hackers can crack that key by sniffing packets that are passing through the air, or they might even be able to compromise a system and simply copy the key. All right, well, if you follow the process here, the client sends an authentication request to the AP. The AP sends a clear text challenge phrase to the client. Basically just a message saying, hey, I want you to do something to this message and send it back to me. The client encrypts the phrase with the shared key and then sends it back to the AP. If the AP can successfully decrypt that message, we've authenticated the client because they have the same key. That was the only way you would be able to encrypt and decrypt the data using this asymmetric process. The key itself is never really exchanged in this process. But once authenticated, then we can go through the association process. And at this point, it really doesn't change. The AP sends an association request. The client sends an association request. The AP sends an association response. Virtual port is opened up, and the client can now send and receive data. WEP obviously is no longer used today. We can crack the key. We can correctly decrypt, capture data once we've captured the key. It had gosh, in weak initialization vectors. There's a whole bunch of vulnerabilities in WEP. And key management doesn't really scale, right? If you have a couple of users, maybe 10 or 20 users, maybe it scales. But if you have 1,000 users, it's just no way to ensure the integrity of the key in that type of environment. In addition, it is a client-only authentication. So that means rogue APs would be allowed. There's no authentication process to authenticate whether or not the access point itself is a legitimate access point. All right. Now, one of the biggest issues with WEP and any of these static key mechanisms was over time the key could be compromised. So what they did is they added TKIP, the Temporal Key Integrity Protocol, with WEP as a basic security mechanism. That's kind of a wrapper around WEP and the RC4 encryption process that was that provided the actual encryption. The encryption algorithm didn't change. The hardware that's used to decrypt and encrypt the data is the same. But the whole idea here is that we're doing rekeying on a temporal basis. That's the whole concept of temporal. Temporal means time. And we're changing keys over a short period of time to ensure the integrity of those keys. Meaning that if somebody is sniffing data and they're trying to derive the keys, that by the time they've gone through different iterations to discover different components of the key has already changed and we've moved on to another key. All right. Now TKIP was carried over. It wasn't originally developed in WEP when WEP was originally deployed. It was an add-on to kind of enhance WEP and then further to enhance WPA. But all of this stuff went out the window when WPA2 was introduced as well. Okay, so it's considered a legacy protocol, not really used. WPA, the Wi-Fi protected access, it is funny, yes. A fly just flew into my mouth and I ate it. Yeah, it is funny. Anyway, we're talking about WPA, Wi-Fi protected access. Drafted as an 802.11i standard. It also uses TKIP because WPA had some of the same weaknesses that WEP had, right? It was designed, remember, these encryption mechanisms were developed based on the hardware that could support these encryption mechanisms. So we had, hardware that could only do certain types of calculations and whatnot. The nice thing about moving from WEP to WPA, though, was that we didn't have to change the hardware. It was backwards compatible with the WEP devices. So we could use 2 different versions of WPA, and this is really what kind of changed the overall security of the protocol itself. You could use pre-shared keys, which is essentially the same concept as WEP, where you have a static key that everybody uses, but you can also implement WPA in what we call enterprise authentication mode, where you have back-end 802.1x authentication. This was a temporary replacement. They already knew in 2003 that they needed to come up with a different standard. It was going to have much stronger encryption, a much better encryption process and key management process. So they developed this WPA, knowing that they were going to come up with WPA2, which was actually introduced the same year that WPA was introduced. The problem with it was WPA2 required that you had to have new hardware. So they had to come up with kind of a middle solution for all those folks that couldn't move to new hardware. All right. In addition, they incorporated the use of the advanced encryption standard, using different blockchaining modes. In this case, they were using counter mode. If you ever get a chance to go take my CISSP course or any of my security classes, you can learn all about the different chaining modes. But The AES-CCMP is essentially counter mode with CBC-MAC protection. This was developed in 2002, so it was a good time frame to kind of integrate this into the use of WPA2. It became officially the successor of DES and triple DES for security around that time frame. Supports encryption links, much larger encryption keys, 128-bit encryption keys, 192-bit encryption keys, and so on, up to 256 bits. Most vendors upgraded their chipsets so that they could do the processing and provide the hardware that's necessary to provide this security. And it's used primarily with WPA2. It could be used with WPA, and then of course it was supposed to replace the whole use of the temporal key integrity protocol. WPA2 was also developed under 802.11i as part of an 802.11i security standard using AES-CCMP. Can also use pre-shared key. We call that WPA2 personal mode versus enterprise authentication. We call that WPA2 enterprise mode. Enterprise authentication means essentially that there's a back-end extensible authentication process like 802.1x or some sort of EAP process. We'll get into that when we start to get into more of the advanced discussions. Currently, this is pretty much the standard today, WPA2. And like I said, we're just introducing these concepts right now. We'll get into the details of these things a little bit later on. Another thing that you can do to enhance the security is you can provide MAC filtering. MAC filtering is a way to enhance your security. Even though MAC addresses can be easily spoofed, it's just another layer of security. We always talk about, when we talk about security, we talk about defense in depth, right? Being able to provide security in multiple layers. So MAC filtering is just another thing that does that. Now there are two ways that we can allow network traffic based on the MAC address of the device. We can have a local entry where the MAC address is configured on the controller, and the maximum number of MAC addresses, it does depend on the platform, but generally it's about 2048 MAC addresses. That local database, by the way, is shared by all local management users. We'll be talking about things like lobby ambassadors, net users, guest users, and so on. And that MAC filter would be shared. So we'll get into the concept of configuring MAC filtering when we start to get into the whole configuration. You can also use Radius, the remote authentication dial-in user service. A Radius server, which is just some software running on a server, allows us to grant access based on conditions that we define, and then we integrate that into the controller. So the controller relays the query or the authentication process to the Radius server, and then the Radius server performs the authentication and responds with the appropriate authenticated or not authenticated method. MAC filtering can be used as part of your overall security strategy, but it's not really very secure. It shouldn't be your only line of defense, in other words, because MAC addresses can be easily spoofed. In addition, and we see this quite often as well, as you add multiple layers of security, you may run into a situation where you're actually making your job much more difficult, and you might end up circumventing some of those security measures because it's just simply too difficult to manage. All right. SSID cloaking, I think you guys pretty much understand what this represents. We're going to hide the SSID from being seen in the beacons. It isn't really recommended as a primary security mechanism because we're not really truly hiding the SSID. And then if you've got BYOD devices or whatever, you need to be able to see that SSID to be able to verify that you're going to be able to connect to the wireless network. And we have synchronization that has to occur and so on. So it's not that it's not done. It certainly is something that we do from time to time, but it certainly should not be a primary line of defense, and and you should consider implementing other more secure methods of securing the wireless network. So we talked about open authentication. That's kind of the default access method. Basically, all you have to do is know the SSID, which in reality you don't because it's broadcast in the beacons. WEP can be used for both authentication and encryption, but it's considered to be insecure and insufficient for needs today. We added the temporal key integrity protocol to kind of enhance the security of WEP. And then, of course, WPA became the replacement, which operated in both personal mode and enterprise mode. WPA2 incorporated the use of personal mode and enterprise mode as well, but it also incorporated the use of a much stronger encryption algorithm, right? Instead of using RC4, we're using the advanced encryption standard with the Reindel algorithm and so on. SSID cloaking, again, not really secure, but it is just another layer of defense, just like MAC filtering. And we'll see what all of these things, how all these things are configured when we start to get into the implementation. All right, so that concludes that lesson. And now we're going to get into our next discussion, lesson number 3, which is taking a look at 802.1x and the extensible protocol, extensible authentication protocol framework.